Hello and welcome to Mr. Tompkins Ed Tech. In this video I'll identify the top 10 most likely topics you'll encounter on a calculated paper and run through some of the typical exam questions to help you prepare for that paper. There is a worksheet that goes with this video and I strongly recommend that you try the questions first yourself before watching. Thanks to Dawn Crichton from Spencer Academies Trust for pulling this worksheet together, by the way. You'll find a link to this paper below, so why not pause the video and go and download it now. Got it already? That's great. The idea is for you to try these questions yourself first, then watch the video to mark and up-level your work. This should help you identify what topics you are solid on and, more importantly, which ones you still need to work on. In the description below the video, you'll find links to further resources on each of these identified topics. So once you've finished here, you can tap on these links to target any areas of weakness that you still might have. Also in the description you'll find a list of further topics that may well also come up. Remember, I've only included the most likely here, but there will be others, and if you have time you should also work through those topics too. If you've not already subscribed and hit the bell, go and do it now. That way you'll be notified when I post more videos to help you succeed in your maths exams. Any questions, make sure you pop them in the comments below the video. Good luck with your preparations, and let's get into it. So first up on my top 10 topics, I've got repeated percentage change. Now often this means compound interest, but also it might be growth and decay questions applied to things in nature or other kind of financial situations. But this first one is about compound interest, isn't it? And it says, Daniel invests £2,500 for 3 years. The compound interest rate is 2.9% per year. Which calculation works out the total value after 3 years? Circle your answer. Okay. So now there is a highly complicated version of the compound interest formula on the formula sheet. Personally, I don't like to use that. I think it's overly burdensome and complicated. If you've ever seen any of my videos before, you know that I use like a little triangle for percentage questions. Put your thumb on it, final, original, multiplier. And I just use an extension of that when I work out repeated percentage change. So using that triangle, final, original, multiplier. Then if you have a look at this, what have I got? Final, original, multiplier, which is which? So final is the thing that we want to find, isn't it? It's what happens after the percentage has been applied. Okay, so that's the thing I want to find. I don't know the final, it's the one I want to find. Okay, the original is the amount I start with. So Daniel invests £2,500, so that's what goes here. And multiplier is just the percentage change written as a multiplier. Okay, so if it's increased by 2.9% a year, then the multiplier is going to be, well, if you've got 100% and you add on 2.9%, then what have you got? You've got 102.9%, which as a multiplier is 1.029. Okay, and so if we're looking for the final, we're going to put our thumb on the one we want to find, which is the final, and that tells me what to do with the other two. Final is equal to original multiplied by the multiplier. Okay, and that's what it is for normal percentages. Now, if you've got a repeated percentage change, we just then need to wrap that in a bracket and raise it to the number of years or the number of times that you're applying it if it's not years. Okay, so that's the kind of just the extended version of what I normally do for percentages. So it's pretty much the same, apart from you wrap multiplier up in a bracket and put years as an index. Okay. So then subbing in what we know, final is the thing we want to find. Original was 2,500. The multiplier is 1.029. And the number of years is 3 years, isn't it? Okay, so we're going to raise that to the power of 3. Okay, so which one of those looks like that? It is that one there. Now part B says Anna invests £2,500 for 3 years. The interest rate is 3.5% for the first year and 2.3% for the second year onwards. Whose investment is worth more after 3 years? Okay, well, her amount is also going to be the original amount, which is 2,500. Now, her percentage changes are different, aren't they, for each of the three? So I can't just take one and raise it to the power of 3. This one, 3.5% is a multiplier. If you've got 100%, you add 3.5%, you've got 103.5%, which as a multiplier is 1.035. And this one is going to be 1.023. Okay, now that one we're going to do twice, so we need to square that one. So to work this one out, when you've got like different amounts each year, you just multiply through by each of the percentage changes that you're making. So I'm doing one lot of 1.035 and I'm doing two lots of 1.023. So I'm going to square that one. Okay, right, so then just tippy tapping that into the old calculator. 2500 times 1.035 times 1.023 squared. I make that 2,707.89. Okay, so that's Anna's amount. Now we need to compare it, don't we, with what Daniel has to see which one is better. So I also need to evaluate this expression I wrote down here as well. So 2,500 times 1.029 raised to the power of 3. What does that one come out to? That comes out to 2723.87. Okay, so we can see then that Anna's investment was worth slightly less than Daniel's. So the answer is going to be Daniel. So question 2 is not compound interest here. Here it isn't. It's growth and decay. So rather than having pounds in the bank that are growing, we've got runners in a race that is growing each year, and we need to work out how many there will be in so many years' time. So a marathon takes place each year. In 2020, there are 6,500 runners. The prediction is that for each of the next 3 years, the number of runners will increase by 5%. Does this predict that in 2023, there will be more than 7,500 runners? You must show your working. Okay, so I'm not going to be using the horrible complicated formula in the formula sheet. I'm just going to use my FOM and I'm going to add a Y on the end for the number of years. So rather than FOM, it's going to be FOMI today. Right, so what's what? What's the final? Final is the thing we want to find. The prediction in 2023, that's what we're looking for. The original is the 6,500 runners that we had to start with. The multiplier is going to be the 5% increase, which as a multiplier then 100% plus 5% is 105%, and that as a multiplier is 1.05, and the number of years in this case is going to be 3. Okay, so we've got all our values and we know that crossing out the final, it's original times multiplier. So final equals original times multiplier. But when you've got repeated percentage change, you just raise that one to the number of years. Okay, so subbing in what we know into that equation. Original is 6,500. The multiplier is 1.05. And the number of years is 3. So tap that into the calculator. 6,500 times 1.05 raised to the power of 3. That is giving me, what's that? 7,524.5. So I'm going to round that off to 7,525 because I don't like the idea of a fractional runner. That would be quite messy. So 7,525. So does this predict that in 2023 there will be more than 7,500? Yeah, there'll be 25 more than that, won't they? So yes, greater than 7,500. Don't forget to answer the question. So the question was, does the prediction predict it's over 7,500? Not just find the answer. Okay, so you need to answer the question. Question 3, the population of butterflies in the park is 4,200. So again, this is growth and decay rather than compound interest. Assume that the population increases by 12% each year. Show that after 20 days, the population would be greater than 40,000. Okay, so drawing my little triangle. And then working out what I've got. F-O-M. I'm still going to use Y. I know it's days, but I'm just going to use Y anyway for consistency. So, right, the final is the thing we want to find, isn't it? Show that after 20 days, it would be greater than that. So we want to find that. That's what we're looking for after the percentage change has happened. The original, what did we start with? The original was 4,200. Okay, what is the multiplier? We're talking about a 12% increase, and that as a multiplier then would be 100% plus 12%. That's 112%, or 1.12 as a multiplier. And years, or it's days in this case, but I'm just going to write years, is 20. Okay, so then final equals original times multiplier raised to number of years or days. In this case it's days. And then so original is 4,200, the multiplier is 1.12, and the number of days is 20. So let's type that into the calculator. 4200 times 1.12 raised to the power of 20. And now that comes out to be a whole lot of butterflies. That's 40,514 and a bit of a butterfly, which I'm just going to try not to think about. Yes, so 40,514. So yes, again, that is greater than 40,000. Okay. And then it says, in fact, the population increases by 13% each day for 19 days, then decreases by 8% for 1 day. After the 20 days, is the actual population greater than 40,000? Tick a box. Show working to support your answer. Okay, so for this one, if we're going to change this to 13% and reduce the number of days to 19, but then add a final multiplier on the end, we're going to get our final is equal to 4,200 times, rather than 1.12, it's going to be 1.13 for our 13%. Rather than 20, we're going to decrease it to 19, but then we're going to add that extra multiplier on the end, which is a decrease of 8%. So if you've got 100% and you subtract 8%, so it's gone down by 8%, that leaves you with 92%, which is a multiplier is 0.92. So I'm going to multiply it at the end by another 0.92 to see what difference that makes. Is it still going to be greater than 40,000? So let's find out. 4200 times 1.13 to the power of 19, and then times that by 0.02. Okay, it's slightly less, isn't it? So that is 394. I'm going to round that up. 403. Okay, so that's 39403 butterflies. So is the actual population greater than 40,000? No, it is not. Slightly less. Question 4. The value of a second-hand car is £9,000. Each year it loses 20% of its value at the start of that year. Work out its value in 4 years' time. Okay. This is what's called in the trade depreciation. So if you ever buy a new car, if you're lucky enough to have that happen to you, then just know that it's going to lose a shed load of money on the very first day that you roll it off the forecourt of the garage. So let's work out what we've got here. So the value of a second-hand car is £9,000. So that is, what's that? Final, original, multiply years. What have we got here then? So that 9,000, that is the original, isn't it? So that goes there. Each year it loses 20% of its value. So if you've got 100% and you subtract 20%, that's 80%, and as a multiplier, that's 0.8. Work out its value. That's what we're trying to do. Work out its value, and then after 4 years' time. So the number of years is 4. Okay. So that's where that all comes from. So then using our triangle, going to cover up the thing on a final. I want to find the final. It's original times multiplier. Final equals original times multiplier. If you've not seen any of my other videos on percentages, you might like this method if you're not very good at percentages. You can use this one formula to do everything, rather than learning a bunch of different bespoke methods depending on if you've got like reverse or percentage change. It just kind of works for all of them. Right, so then subbing what we've got. So the original is 9,000. I'm going to multiply that by the multiplier of 0.8, and I'm going to raise that to the power of 4 because it's 4 years. So what we got, 9,000 times 0.8 to the power of 4. That comes out to be £3,686.40. So it's pretty much lost 2/3 of its value then, isn't it, in 4 years. Question 5. The number of hedgehogs in England is expected to reduce, oh no, that's so sad, by 4% each year. Assume that there are now 1,000 hedgehogs in England. I don't want to do this question. Work out the expected number of hedgehogs in England after 5 years. You must show your work in. Okay, so final original multiplier. So this is the decay part of growth and decay, similar to depreciation. So the depreciation of hedgehogs, bless them. Right, so what we've got here then, so the final, that's what we're trying to find, isn't it? Work out the expected number of hedgehogs. So that's the thing that we want to find. Okay, so then the original, what's the original? We're starting with 1 million hedgehogs. It's actually not a lot of hedgehogs if you think about it. 1 million. And then the multiplier, what's that? That's going to be a reduction of 4% each year. So if you've got 100% and you subtract 4%, that's 96%, which is a multiplier is 0.96. Okay, so that's my multiplier. And then finally, the number of years in this case is 5 years, isn't it? Okay, so that's 5. Okay, so cross enough the thing I want to find. Final. Final equals original times multiplier. Raised to the number of years. So that's 1 million times 0.96 raised to the power of 5. Okay, I shall try not to cry when we work this out. So that's 815,373 hedgehogs remaining. 815,373. Okay. Right, question 6. £2,448 is invested in an account at a rate of compound interest. 1 year after the investment, there is £2,496 and 96 pence in the account. How much money is in the account 4 years after the investment? Right, we've got 2 steps to this problem. I'm going to need more space. Okay, so we've got 2 steps to this problem. First off, I need to work out the percentage change. Okay, so I'm going to do a kind of a normal percentage change first. So final original multiplier. Now it's the multiplier we're trying to find here, isn't it? That's the thing we don't know. Okay, because it says, well, we need it for the second part of the question. So we're going to have to find that first using the final after the first year, which is that. Okay, that's going to be 2,496.96. Okay, and then the original was that one there, isn't it? Okay, that's how much money we started with. So that's 2,448. Okay, final original multiplier. So the first thing we're trying to find here is m, the multiplier. Okay, so we want to work out what the annual interest rate is, and then we can do the compound interest afterwards. Okay, so the multiplier is equal to the final divided by the original. Okay, so in this question that is 249696 divided by 2448. What's that then? 2496.96 divided by 2448. Now I make that 1.02. Okay, so that's my multiplier. It's basically a 2% increase each year, isn't it? But I'm just going to use that multiplier in the next part of the question. So in the next part of the question, I've got final original multiplier FOM, and this time y as well. So now the final is the thing we want to find, isn't it? We want to know the investment after, how much is the account worth after the investment. So that is the final we're looking for now. The original is still the original that we had at the beginning. Okay, so that is 2448. The multiplier is the multiplier that we found, 1.02. And then the number of years is going to be 4 years from the question, isn't it? So that's equal to 4. Okay, so covering up the thing I want to find now, I'm going back to finding the final. So the final equals original times multiplier. So what's that then? That's going to be 2448 times 1.02 raised to the power of 4. 2448 times 1.02 raised to the power of 4, and that comes to 264979. Okay? Yeah, that's our final answer. 2649.79. Question 6. Use a ruler and compasses for this question. A ship is closer to port X than port Y, less than 11 kilometers from Y. The map shows the position of X and Y. On the map, show the region where the ship could be. Label it R. So we're going to have to use our knowledge of loci of various points, and along with our compass skills, to work out what the answer is. Now, firstly, just a little bit of kit care. Make sure you've got a small sharp pencil. Make sure that the tip of the pencil and the tip of the compass line up. Make sure it's a short pencil so that when you twirl it at the end, it doesn't bump into your fingers. And make sure it's not too loose, and if it is, make sure you tighten it up before the exam with a screwdriver. Okay, so we're going to have to form a loci of points for the closer to port X than port Y. Now, the points that are equidistant are going to be the perpendicular bisector of the line XY. So to form a perpendicular bisector, we set our compasses to more than half of the distance between the 2 points, and we draw an arc from X and an arc from Y. And you should notice that these two arcs cross at 2 points. So with our ruler, we're going to line up our ruler with those two points of intersection and draw on our perpendicular bisector. Now all the points on this line are the same distance from X as they are from Y. So we're looking for the points to the left of that line then, so that they're close to X and Y. Right, now next we need to work out the points which are less than 11 kilometers from Y. Now the scale of this diagram is 1 centimeter represents 2 kilometers. So taking 11 and divide it by 2, I should have a distance of 5.5 centimeters on my diagram. So we need to get our compasses out again. We need to set it to 5.5 centimeters. So we can use the marks on our ruler to make sure the distance between the tip and the pencil is exactly 5.5. And then we can draw a second arc based on Y. Again, every point on this line is going to be 11 kilometers from Y. Oops, let's just do that again. My tip slipped. Okay, so all the points on this line are 11 kilometers from Y. So inside the circle must be less than 11 kilometers from Y. So then the region we want has got to be inside that circle and to the left of our perpendicular bisector. So it's this area here. Don't forget to label it R. It says that specifically in the question, and if you don't remember to do that part, you will lose a mark. Okay, all done. Use a ruler and compasses in this question. A, B, C, D represents a garden. A tree is to be planted in the garden. The tree will be in the region that is closer to AB than to BC. Label the region R where the tree could be planted. Show all your construction lines. Okay, so first off with construction questions like this, we're going to use a pair of compasses. Okay, so when you're setting up your pair of compasses, make sure you've got a nice short pencil and that your pencil tip and the tip of the compass are in the same place. Right, now the locus of points that is equidistant from two lines A and BC is an angle bisector. So we're going to stick the compass point in B and draw an arc that cuts both AB and BC. Then we're going to move the compass point to one of those points where it crossed, draw an arc in the between, and then move it to the other point where it crossed and draw a second arc in between. Now you should find that these two arcs then form a little cross, okay? And then to form our angle bisector then, we're going to join the point B through that point there where the two lines crossed, okay? And that's going to be my angle bisector. Now I'm going to draw this all the way through the garden and out the other side. This line is going to cut my garden into two regions, okay? Now I want the region that is closer to the line AB. So which half is that then? Okay, well you can see that it's going to be on this side of the line. That's going to be closer to AB because all the points on the line are equidistant. So on that side of the line they're going to be closer to AB, and on the other side they're going to be closer to BC. So let's just draw an R there. Question 6. ABCD represents the plan of a field. There is a path across the field that starts at A, is the same distance from B, A and BC. Using ruler and compasses, show the position of the path. Okay, so make sure you keep yourself a Ickle pencil that you can use with your compass. Okay, you need a special one really. Don't have like your normal long pencil, it's too long. Okay, the reason for that is when you twirl your compass around, it needs to kind of do a full 360 without bumping into your fingers. Okay, right, what we need to do is to create an angle bisector at B. So putting your compass point at B, drawing an arc that crosses BA and BC at the same distance, so without changing the aperture. And then move the compass point to the mark that you made and draw a mark in the middle. Sorry, can't really see that very well. And then move it to the other side and draw another arc that crosses your other arc that you just drew. And then that gives you a point where you can pass through and draw your bisector. So then just grab a ruler, draw a line from B through the cross that you made, and then out the other side. That's going to be the path. Okay, now don't rub out your construction marks. The construction marks need to be there in order for you to score the marks. So if you rub them out, you'll lose marks. Leave them there. They have to be visible, otherwise you won't score both. All right, let's move on. Next up, we've got angles, and we need to know a whole bunch of angle facts for this this exam. We need to know all the basic ones, so we need to know angles in a straight line, which sum to 180 degrees. We need to know angles meeting at a point, which sum to 360. We need to know vertically opposite angles that are equal. We need to know angles in parallel lines. So we've got corresponding we've got alternate, and we've got co-interior. So you need to know about those. And we also need to know about polygons. Okay, so in a polygon, so for polygons, you've got the sum of the interior angles. That's going to be the number of triangles, which is the number of sides minus 2 times 180. That will tell you what the interior angles are. Then if you divide that by n, you'll get one individual one in a regular shape. And the exterior angles, they always sum to 360. So if you divide that by n, you'll get each one in a regular one. And you need to remember that interior plus exterior equals 180, doesn't it? Because they kind of lie on a straight line each time, don't they? So that one and that one, that's the interior, that's the exterior one, isn't it? So interior is that one there, and exterior is that one there. Okay, so if you add them together, you always get a straight line. Right, so this first one, question 10, this is a part of a regular polygon with 15 sides shown. Work out the size of the interior angle. Now you could use the interior angle sum. I tend to just stick with the exterior one though, because it's easier. So if I work out the exterior angle first, and I use the fact that the two things add up to 180 to find the other one. Now you can just plug them straight into the interior sum and work that one out. You can do that one as well. But I tend to, for ease, I think the exterior sum one is easier to learn, so I just work out exterior first. Exterior equals 360 divided by number of sides, which is 15. 360 divided by 15, that's 24. And so the interior, that's going to be 180 minus 24, because they were summed to 180 degrees. And that equals 156, doesn't it? So that's 156 degrees. Question 11. Two congruent regular polygons are joined together. Work out the number of sides on each polygon. Now, if these things are congruent, it means they're the same shape, same size, same angles. So if I take this line up here and extend it like that, then that should cut that line in half, shouldn't it? Okay, so that one there is going to be 30, and the other one's going to be 30 as well. And that's what we call an exterior angle, isn't it? And we know that the exterior angles of a regular polygon is equal to 360 divided by n, the number of sides. Now here we know the angle, it's 30, so 30 equals 360 divided by n. So switching those around, cross multiplying those around, bringing the 30 down, bringing the n up, I'm going to get n is equal to 360 divided by 30. 30 goes into 360 12 times, doesn't it? So this is a 12-sided shape. Okay, so it's a 12-sided polygon. Question 12. A, B, B, C, D, C, D, D, E are four sides of a regular decagon. So this decagon continues, doesn't it? It kind of goes around here and back around like that, but we just got like a little slice of it. Okay, work out the size of the angle W. Well, it might have been originally from a decagon, but now it's a 1, 2, 3, 4, 5-sided shape. It's a pentagon, isn't it? Okay, so what do the interior angles of a pentagon add up to? So interior sum is going to be number of triangles, which is always 2 less than number of sides, times 180. So 5 sides, 3 triangles, 3 lots of 180. That's 540 then, isn't it? So the sum of these angles should add up to 540 degrees. Now a regular decagon, each of those interior angles of those, that's the interior angle of a regular decagon. So for a decagon, so again we could use n minus 2. Well, let's just do it that way. I'll show you the other way. I usually work out exterior angles, but I'll show you how to do it the other way as well. So if I want to work out a decagon interior angle from a regular one, the interior angle is going to be equal to n minus 2, the number of triangles, times 180 divided by n, the number of sides. Okay, so 10 sides, 8 triangles, 8 times 180 divided by 10 sides. What's that then? So 8 times 180 divided by 10. It just ends up using bigger numbers. So that's 144 degrees. So each one of those is 144. So that's 144, 144, 144. Okay, so I know those three, and I know the other two are W. So then I can say in the pentagon, then I've got the 5 angles should add up to 540, shouldn't it? So the 140 plus the 140, so 144, sorry, and the 144 plus the W plus the W, they're my 5 angles. So they should sum to 540. So what are those three added together? 144 times 3, that's 432. So that means I've got 2W plus 432 is equal to 540. So then 2W is equal to 540, take away 432. That's 108. Okay, and then so W then is going to be 108 divided by 2 then, because there's 2 of them, isn't it? So that's 54. So each one is going to be 54. Question 13, the diagram shows a triangle and a trapezium. Prove that A is equal to B. Okay, interesting question. So we've got angles at a point here, haven't we? So we know that these add up to 360 degrees. That's 360 there. Okay, so then I can say then that A plus C plus 65 plus 115, that is equal to 360. So adding these two together, 65 and 115, that adds up to 180, doesn't it? So that means that A plus C is equal to 180. Okay, so that's one equation that I know. And then I can work out a second equation in the trapezium by the fact that this angle here is co-interior with this one here, isn't it? So when you've got a pair of parallel lines, I said earlier, and a line crossing them, call that a transversal, then this angle and this angle are called co-interior, and they sum to 180, don't they? Okay, so that's what we've got going on here. So like the green one is like the C and the blue one is like the B, isn't it? Okay, so we know that those two add up to 180 degrees. So I suppose we should, if it's saying prove, and we should really say what the rules are. So I just kind of wrote that down. I'm just going to put in brackets the reason. Angles at a point sum to 360. So to prove that one, you really need to state the rule that you're using. And I can say that C plus B is equal to 180, and that's because we've got co-interior angles. Okay, and so I've got two equations. Let's call that equation 2. Just budge that along, looks a bit neater. So I've got equation 1 and equation 2. So I want to get an equation in A and B. And can you see that I've got C in both of these, C and C? So if I rearrange 2 and make it in terms of C and then sub it into equation 1, so I'm going to rearrange equation 2 and substitute into equation 1, then I'm going to get A plus C. Well, C is 180 minus B, isn't it? So C is 180 minus B, and that is equal to 180. Just take in C, rearranging it, make C the subject, and replacing C in equation 1 with what I've got. I get that. So then removing the brackets, I'm going to get A plus 180 minus B is equal to 180. So I've got 108 on both sides. They're going to cancel each other out. And then if I add B to both sides or move B to the other side, I'm going to get A is equal to B then, isn't it, as required. Okay, I'm just going to say that, you know, it's important with prove that questions that you actually do give the reasons that you are that you are using in order to work through the problem. The angles are not good enough by themselves. You have to say the rule that you're referring to in order to get to that answer. Question 14, ABCD is a parallelogram. Don't know why it's all the way up there. And we're told that C is equal to CE is equal to CF. Prove that Y is equal to X. Well, I know that opposite angles in a parallelogram are equal. So that one there must be 2x as well. And I've got 90 and 90 there, so I should be able to work out that angle at C then, shouldn't I? So I'm going to say that the angle BCD is equal to angle BAD, and that's equal to 2x. And the reason for that is opposite angles in a parallelogram. Okay, that's my first conclusion, and now I've got angles at a point that I can use here, aren't I, to find I can find the angle at C. So I can say that 2x plus the 290 degrees plus my angle, what's that, F, shouldn't really put that blue thing in the way, it's a bit in the way, so my angle FCE equals 360, and that's because of angles at a point, sum to 180. Okay, so then just tidying that up then, I'm going to say that angle FCE is equal to, taking those 290s away from 360, that's going to give me 180, and then taking the 2x to the other side, I'm going to get FC equals 180 minus 2x. Okay, and then that triangle there is isosceles, isn't it? So in isosceles triangles, base angles are equal. Okay, so that one up there is also y. Okay, and so if I take what I've got away from 180 and divide by 2, then I'll find the base angle. Okay, so I'm going to say triangle FCE is isosceles. So what does that tell me? So if it's isosceles, base angles are equals. Okay, so that angle there is y. So what we've got then is we've got angle FCE plus y is equal to 180 degrees because of angles in a triangle. Okay, so then we know that FCE, we just found it, we found it here, didn't we, is 180 minus 2x. So replacing that in there then, so I get 180 minus 2x plus my y plus y, that's plus 2y, is equal to 180. Okay, so then that 180 and that 180 cancel, so I've basically got 2y minus 2x is equal to 0, then am I? So taking the x to the other side, I've got 2y is equal to 2x, and then dividing through by 2, then I'm going to have y is equal to x as required. Okay, so again, just make sure you're writing the rules down that you're using as you're going through as statements, as well as doing the maths. Okay, next up we've got Pythagoras and trigonometry. So this section is all about right angle triangles. So in a right angle triangle, if I've got three sides, A, B, and C, then C squared equals A squared plus B squared. Don't forget, if you're finding one of the shorter sides, it's going to be subtraction, isn't it? So A squared is going to be C squared minus B squared. And then for trigonometry involves sides and angles. So you've got your three trigonometric ratios that you can use: sine, cosine, tangent. So first up, question 15. The diagram shows rectangle ABDE and a right angle triangle ABC. AC is 17, BC is 8. Not drawn accurately. I always just double check that these things are on the diagram. They are. Look, there they are there. But sometimes you get extra information in the text that isn't on the diagram. So before I even ever look at these problems, I just check the word in and make sure everything's on the diagram. So look, so here's something that isn't on the diagram. The ratio of BC to CD is in the ratio of 1 to 2. So where's BC? BC is down there, and CD is over there then. So I've got BC and I've got CD over there. Okay, so if these are in a ratio of 1 to 2, then we know that BC is 8. Then the other one is going to be, well, we're timesing by 8, aren't we? Timesing up by a factor of 8. So this side timesing up by a factor of 8. That's going to give me 16. So that side there is 16 centimeters. Okay. So work out the area of rectangle ABDE. So work out the area of the rectangle. So to work out area of a rectangle, area is equal to length times width, isn't it? So I've got the length. It's going to be my 8 plus my 16 added together. It's going to be 24. And I'm going to have to multiply that by the width, but I don't have the width yet. Okay, I've only got one length. So I'm going to have to use something to work out this side here. Now I've got two sides of a right angle triangle, so it's going to be Pythagoras. So using Pythagoras theorem, then it's the shorter side that I'm trying to find, isn't it? So I'm going to do a squared equals c squared minus b squared in this case. Okay, so that's going to be 17 squared minus 8 squared. Now we're just going to type that straight into the calculator to find it. So I'm just going to press the root key, and then I'm going to put the 17 squared minus the 8 squared underneath it, and then write down the answer. That's 15, isn't it? So then A is equal to 15. Okay, so that's my side there, 15. So if that's 15, then that's 15 there that I need to multiply my width by. So 8 plus 16 is 24. 24 times 15, that gives me an area of 360 centimeters squared. Question 16, this shape is made from two right angle triangles and a rectangle. Work out the size of angle X. So there's angle X all the way over there. Can't really start in that triangle though. We only know one thing. That's not enough to use either Pythagoras or trigonometry. No, you need to know two things in the triangle in order to use those. So we know two things over here. We've got this angle down here, which is 62, and we know that this side here is 5 centimeters. So I'm going to start in this one. We've got angles inside, so this time it's trigonometry. So let's label up the sides. The long side is always the hypotenuse. This is the opposite because it's opposite the angle. Okay, and then the 5 then is going to be the adjacent. Okay, so just thinking about SOHCAHTOA, which ratio we're going to be using here. Okay, now I usually decide by looking at the one that I don't want. Now which one do we want to find? I don't think we're interested in H. I think we want to know the height of this, don't we? We don't really need to know the slant height. So I'm not that massively interested in H. So the ratios have got H in it. I'm not interested in either. So I'm not interested in sine or cosine because they've both got a H in it. I'm after the TOA part, tan. So let's write out the tangent. So tan theta is equal to the op over the edge, opposite over adjacent. Subbing in what I know. So then tan 62 is equal to our opposite. Let's call it H because it's the height of the shape, isn't it? I like that better. So let's call that H divided by the adjacent, which is 5. Okay, so then rearranging that, H then is going to be 5 tan 62 then, isn't it? So H equals 5 tan 62. Typing that into the calculator. 5 tan 62. Just get into the habit of writing down everything you're going to type into the calculator before you type it in. 9.40. I'm going to write down 9.40. I'm going to keep the full calculator display though because I'm going to use that in my next calculation. Okay, so just retain it as you go along. Okay, so then moving over into the other triangle. So I now know that this side here is also equal to H. It's also 9.4, isn't it? And so now I've got, what have I got in this triangle? I know the hypotenuse here. I know the opposite. I don't know the adjacent. I'm not actually that bothered about the adjacent. What am I trying to find here? I'm trying to find the angle. So this time, if I write down SOHCAHTOA, this time it's the adjacent I don't really care very much about. I know the opposite, I know the hypotenuse, I don't know the adjacent. So all the ones with the adjacent in I don't want. So I don't want CA and I don't want TOA, I want SOH this time. So in the second triangle I'm going to be using sine. So sine theta is equal to op over hype. Okay, so subbing in what we know, we're actually trying to find the sine of x here, aren't we? We're trying to find the angle eventually. So the opposite is going to be our 9.4. I'm going to write 9.4 over, I'm going to use the full calculate display, and then I'm going to divide through by the hypotenuse, which is 12. Okay, so then if I want x, then I then need to do the inverse sine of that, don't I? So x is going to be the inverse sine of 9.40 divided by 12. So on my calculator, I'm going to press Shift, Sine, so make sure I've got sine to the -1 on the display, then the answer over 12, okay? Brackets seem to be optional, but sometimes they matter, and that comes out to be 51.5. Now I'm going to round it off to 51.6, so that is 51.6 degrees. Okay. Question 17. A pentagon is made from a square and an isosceles triangle. Okay, so we've got a square and a triangle stuck on the top of it. And it says work out the perimeter of the pentagon. Okay. So to work out the perimeter then, we know this side, and this side, because it's a square. We know they're just 12, 12, 12. What we need to do is work out these two sides. Now they're both the same because it's an isosceles triangle, but we need to find them nonetheless. And now in order to do that, we're going to add a few extra lines into my diagram. Okay, I'm going to make a line across here. And I'm also going to make a line going in this direction because I'm not sure that angle at the top. It looks quite right angle-ish, but it's not drawn accurately. And I'm not going to be fooled into thinking I can just make it a right angle. Okay, so I'm going to make the right angle. I need a right angle for trigonometry, so I'm going to add the right angle there. Okay, so if that whole angle there is 125, remember this bit here is 90, so the rest of it there is going to be the difference between 90 and 125, so that's 35, isn't it? So I know that's 35, and I know the distance all the way along the bottom is 12, but my line I dropped down there cuts it in two, so this side of it is going to be 6. And what I want to do then is work out this side, the hypotenuse. I want the hypotenuse. That's what I want. Okay, I've been given, well, I've worked out for myself the adjacent. This is the opposite, which I don't really care about so much. So writing down SOHCAHTOA. Now here I want the perimeter, so I want the hypotenuse. I've got the adjacent, I don't have the opposite, not particularly interested in it. So the ones with O in it, I don't care about so much. It's this one here, the cosine I need for this question. So I'm going to write down the cosine formula. Cos theta is equal to adjacent divided by hypotenuse. Okay, subbing into the formula, cos 35 is equal to the adjacent, which is 6, divided by the hype, which I'm trying to find. Okay, so then rearranging that then, so our hype then is going to be equal to our 6 divided by the cos of 35. These two swap around, don't they? When you've got the thing you want to find at the bottom, you just kind of switch these two around like that. So it's 6 divided by cos 35 into the calculator, 6 divided by cos 35, that comes out to be 7.32 and change. Okay, so I'm going to write down three significant figures, 7.32, but I'm just going to retain that in my calculator for the final calculation. Okay, so then finally the perimeter is going to be the 12 plus the 12 plus the 12 plus the 7.32 plus the 7.32, the two equal sides along there. Okay, so I've written down 7.32, but I am going to use the calculated value. So I'm going to take my last value, I'm going to times it by 2, and I'm going to add on 3 lots of 12, and that comes to 50.64. So I'm going to round that down to 50.6. And that's going to be in centimeters then, isn't it? So that's my final answer, 50.6. Question 18, work out the area of the trapezium. Okay, so to work out an area of a trapezium, we need to know, what's the formula? Area is equal to a half A plus B times H. Okay, so we know A, it's that one. We know B, it's that one. Do we know H? No, we don't. That's the one we're missing at the moment. That's the height there that we need. Okay, so we need to work out the height. Now, luckily, we've got an angle. So if I add another line over here, we can make a triangle over this side with a right angle in it. That would be helpful, wouldn't it? Because then we can use trig. Okay, so there's my right angle there. Now, do we know any lengths now? We've got an angle, so that's one thing. We need to know one other thing. It'd be helpful if I knew this side here, for instance. I can work that one out, can't I? Because it's a right angle over here, and I know that's 11 and that's 15, then this bit here must be the difference between 15 and 11. It must be 4, mustn't it? Okay, so that angle, that length there is 4. Now that is the adjacent. This is the hypotenuse, that's the slant height. But for the trapezium, we want that height, don't we? We want the opposite. We want the height of the trapezium, not the slant height. So we want the opposite here. We don't want the hypotenuse. We know the adjacent. So using SOHCAHTOA, which ratio is that then? So I'm not interested in the hype. So no SOH and no CA because they've got a H in it. That leaves me with that one, the TOA part. So tan theta is equal to the opposite divided by the adjacent. So the angle is 64, so tan 64. The opposite is the one I want to find. I'm going to call that the height of the shape because it matches with my formula down there. And then the adjacent is going to be 4. So then H is going to be 4 tan 64 then, isn't it? Type that into the calculator. 4 tan 64. That's 8.20. Okay, so again, I'm going to retain that value in my calculator for my next calculation. Let's just sub in what I've got. I've got half times 11 plus 15 times 8.2 then, isn't it? Okay, so I'm going to just use my answer key to type that in at the end then. So it's 0.5 times 11 plus 15, that's 26. So 0.5 times 26 times answer. That comes out to be 106.6, which I'm just going to round off to 107. Going to round it off to 107 centimeters. Question 19, the length of the diagonal of the cuboid is 20 centimeters. Now here's an example again where there's information in the question that's not on the diagram. Okay, so always read it through and add it to the diagram as you go along. So the length of the diagonal, that's the long line going from one corner to the opposite corner. So that is 20 along there. Okay, the diagonal makes an angle of 24 degrees with the base. That is on the diagram. The area of the base is 150. That isn't on the diagram. Okay, so let's just add that in. So the area of that is 150 centimeters, isn't it? 150 centimeters squared. Work out the volume. Okay, now to work out the volume of a cuboid, you need length times width times height. Now we've already kind of got the length times width because we've got the area of the bottom, and the area of a rectangle is length times width, isn't it? So if the volume is equal to length times width times height, then the yellow bit is already the length and the width. Okay, so that's going to be the amount here that we said is 150. So those two bits together is 150. So all we really need to do is work out h, the height of the cuboid. Now the height of the cuboid is this length here, isn't it? That's the height. Now that is one of the sides of a right angle triangle that runs up the middle of the the shape like this. Can you see that one in there? Okay, so that's the triangle we're going to be using here. So that triangle has got an angle of 24 there. The right angle is this one down here, look at the bottom. And we want to know this side, the H up here. Now the H in this one is actually the opposite, isn't it? It's the opposite the angle. The 20 is the hypotenuse. The adjacent is this side here, which we don't know, we don't really particularly care about. Okay, so writing down SOHCAHTOA to work out which ratio we're going to use here, because it's definitely trig, isn't it? It's the A that I don't care about. So no Ka, no Toa, because they've both got an A in it. I'm going to be using sine to work out the length of that opposite side there. Okay, so putting in the things that we know into the formula. So sine theta is equal to the opposite over the hypotenuse. So the sine of 24 is equal to H, the height of my cuboid, divided by the hypotenuse, which was 20. Rearranging for the height is equal to 20 sine 24, and tapping that into the calculator. 20 sine 24, that comes out to be 8.13 and change, equals 8.13. Okay, now as per always, I'm going to write down 8.13, but I'm going to retain the full calculator value to retain accuracy for my final answer. So I'm going to take my answer from the last question, I'm going to times it by 150. That's going to give me 1220.2, which I'm just going to round off to 1220. Right, job done. Question 20, the volume of a pyramid is 1/3 of its area of its base times its perpendicular height. VABCD is a rectangular based pyramid with volume 640 centimeters cubed. X is the center of the horizontal base directly below V. Okay, work out the angle between VC and the base. So work out the angle between VC and the base. So the angle between VC and the base, we're talking about that angle there, aren't we? Okay, between that edge VC and the line XC. That's the angle that we're looking for. Okay, right, what do we know? We've got the formula for the volume of a pyramid. I'm sure that's going to come in handy. And we know that the rectangular base is 16 by 10. So we know the area of this base, don't we? We've got the area of this base. We can work it out. Okay, and we've got the volume. So from that, we should be able to work out the perpendicular height. Okay, so area of base, that's going to be 10 times 16. That's 160. Okay, and then we know that the volume is 1/3 of area of base, which we just found, times the perpendicular height. Okay, now we know the volume. It was given here, so we know that the volume is 640. We know the area of the base because we just worked it out, so we know that. We know what 1/3 is, and that just leaves a height, so we can use this then to find the perpendicular height of the pyramid. So let's sub in the things that we know then. So 640 is equal to 1/3 times the area of the base, which is 160, times the height. Okay, which we're going to find. Just put height in there so I know what I'm finding. So rearranging that then, I'm going to cross multiply that 3 and 160. So that means H then is going to be 640 times 3. So I'm going to move, cross multiply that up there. And this is going to cross multiply and end up down on the bottom, isn't it? So it's going to be 640 over times 3 over 160, and that's going to be H. So let's work that out then. 640 times 3 divided by 160, that comes out to be 12. So H is 12. Okay, so we know the height now is 12. Let's just add that to the diagram. So we've got the height. What else have we got? Well, we only still know one thing in that triangle, so we're not going to be able to find the angle just yet. We could use Pythagoras. Ooh, why's my ruler gone over there? Well, that's behaving very strangely. It doesn't normally do that. Glitchy virtual ruler. So let's just, oh, it's behaving itself again now. Let's just extend this line down here to the other side. Okay, so we've got a right angle triangle here, don't we? So if we have a look in here, look, this is a right angle triangle of which we know two sides, and we want the hypotenuse then, don't we? So we can use Pythagoras theorem in that little part there. So in triangle ABC, what we're doing, we're using Pythagoras theorem. We're going to be using c squared equals a squared plus b squared. So so that's ac squared, isn't it? So ac squared is equal to 10 squared plus 16 squared. So then AC is going to be the root of 10 squared plus 16 squared, isn't it? So square root 10 squared plus 16 squared. I make that 2 lots of root 89. Okay, I'm just going to leave it in root form for now. So then, but I don't want AC, do I? I want XC, and that's half AC, isn't it? So XC is going to be half AC. So that's just going to be a root of 89. Okay, so now I know this side here is root 89. Okay, from X to C, and then I've got a height of 12. I can use trig in that triangle now, can't I? So now I can switch to triangle. So in triangle VXC, it's always a good idea just to say what you're doing and where you're doing it in these things. Just make sure work easier for the examiner to follow. Okay, they want to award you marks, but they need to understand what it is you're doing. So just make it clear to them what it is you're doing. So I'm going to be using SOHCAHTOA again here. SOHCAHTOA. Which one am I going to use here? I've got, well, the angle is the one I want to find is down there. So this is the adjacent and this is the opposite, isn't it? So H don't really care about so much. So no SO, no CA. It's the TOA one that I'm after. So tan theta is equal to the opposite over the adjacent. So tan theta is equal to 12, which is the opposite over the root of 89, which is the adjacent. So then what I want then is theta, though I don't want tan theta, so I'm going to do theta is equal to the inverse tangent of 12 over the root of 89. So what's that? So shift tan 12 over root 89. Apparently that's 51.8. 51.8 degrees. Lovely. Moving swiftly along, we're going on to averages from a frequency table. So you need to understand about data being grouped and what that means in terms of the means, medians, modes. So in question 21, here is some information about the times taken for 40 people to fill in the form. In which class interval is the median? Now, if you think about it, if you have 40 people in the line, then the median person is the person in the middle. So if you've got 40 people, who's the middle person? You can find the median by taking the number of people, adding 1 and dividing by 2. So it's the 20.5th person in your list, or between the 20th and the 21st person. Okay, so if we can work out where the 20th person is and the 21st person, hopefully they're both in the same group, and then we could declare that one to be the median. Okay, right, or the median group. So where is the 20th person? You can use that. You can use like cumulative frequency to kind of track them down. So if we rank them from fastest to slowest, then the fastest 3 people are going to be ones with those times there, aren't we? Okay, and then the next 9, the next fastest, are going to be those 9 there. That takes me up to 12 people altogether. So the first 12 people are in there. Okay, and then the next 11 people are in the next group. That takes me all the way up to person 23. Okay, so if person 1 to 3 is in the first group, and person 4 to 12 is in the second group, and person 13 to 23 is in the third group, then person 20 and person 21 are both in this group here then, aren't they? They must be both in here. So then my answer is that one. Question 22, here's a frequency table for the times taken to solve a puzzle. Which class interval contains the median? So it's pretty much the same question. So we're going to do it the same way. If I take the number of people in the survey, which is 100, if I add 1 and divide by 2, then the median is going to be the 50.5th person then, isn't it, in this data set? Where is this 50.50th person? So if I work out cumulative frequency, then the first 38 people are in here, so person 1 through 38. The next 16 that are in here, that would take me up to 54 in cumulative frequency. So that means the 39th to the 54th person are in that group, and that means the 50th and the 51st person are in this group here, isn't it? So which class interval is the median in? It's going to be in the 1 less than t less than equal to 2 category. Question 23, the table shows information about the distances walked by 120 students on their way to school 1 week. Okay, so the distance to school is in the first column, 0 to 5, 5 to 10, 10 to 15, 15 to 20. And we got the frequencies of each of those distances, the number of students who walk those distances. Now we want to estimate the mean, estimated mean. That means I need to make an estimate somewhere, so I can estimate the mean. And the estimate is the fact that you don't actually know exactly how far these students walked. So normally when you work out a mean, you add up all the distances, then you divide by the total number of things, and then that gives you your mean. But we don't know the precise amounts, do we? Because we just know that these 20 students here, look, they walked somewhere between 0 and 5 miles. But how many exactly was it? We don't know. That information is not provided to us. So if we want to add up these amounts of unknown values between 0 and 5, we're going to have to estimate the distance that each one of these 20 people took. And we tend to use the mid value for that. We use the mid value of each category, and we say, well, we don't know how far each of those 20 went. So let's say it's the mid value. Let's assume that everyone walked the middle amount of that group. Okay, so the first thing we're going to do is find all the mid-x values. Okay, so mid-x for the first category is halfway between 0 and 5. Add them together, divide by 2, you get 2.5. 5 plus 10 is 15, divided by 2 is 7.5. 10 plus 15 is 25, halve it, you'll get 12.5. And then 15 plus 20 is 35, halve it, you're going to get 17.5. Okay, so we're going to use those to represent the amount of miles each student walked in each of those categories. And then we're going to do frequency times mid-x for this one. So 20 students walked, we're estimating 2.5 miles each. If we multiply those, 20 times 2.5, that means we're estimating that those 20 students walked 50 miles between them. Okay, we're going to keep doing that down the table, just multiplying these together all the way down. So 48 times 7.5, that comes out to be 360. 30 times 12.5, that comes out to be 3375. 22 times 17.5, that comes out to be 385. And now we need the total. We just need to add all those up then, don't we? So 385 plus 375 plus 360 plus 50. That comes to 1,170. Okay, so then my estimated mean is going to be sigma fx. Sigma fx is this one, the sum of the frequencies times the x values divided by sigma f. Yeah, sigma has a real meaning, kids. It doesn't mean what you think it means. It's a Greek letter. Come on. So sigma f is equal to 120. So that's 1170 divided by 120. So what's that then? 1170 divided by 120. That comes to 9.75. 9.75 miles. Now, before you move off, just think, is my answer sensible? Okay, I see many students messing these up and write down a ridiculous number because they forget to divide, or they don't forget to multiply, or they forget to find the mid-values. I don't know, lots of different reasons. But before you move on, just look at your answer. Is my answer sensible? 9.75. Where would that appear in this table? It would be here, wouldn't it? Towards the end of that second group, which is pretty much in the range, isn't it? So just think, is my answer sensible? If you have a look at there, you know, masses of people in the middle there. I think 9.75 looks very sensible as an answer. It's kind of in the middle of the distances everybody walked. Okay, so don't move on before you just think, is my answer sensible? And if it isn't, go back and check, because you've made an error. Question 24. An athlete runs in 10,000 meter races. The table shows the times for his last 20 races. So I've got time in T minutes. Some races he ran 30 to 32, then 32 to 34, 34 to 36, 36 to 38 on various frequencies. We need to calculate an estimate of his mean time. Okay, so going to do the same thing as the last question. I'm going to find the mid values first, so mid T, and then we're going to do FT. Okay, frequency times the mid T. Okay, so what is the mid value of 30 to 32? That's going to be 31. Middle of 32 and 34 is 33. Middle of 34 and 36 is 35. Middle of 36 and 38 is 37. Okay, then we're going to times these. 3 times 31, that's 93. 9 times 33, that's 297. 6 times 35, that comes to 210. 2 times 37, that's going to be 74. Okay, so sigma f, the sum of the frequencies, that is going to be equal to 20, because it tells us in there, already tells us there, look, but we can add them up as well if it doesn't. And sigma ft, the sum of the frequencies times the times, that's going to be 74 plus 210 plus 297 plus 93. 4 values comes to 674. Okay, so now once I've got those, then my estimated mean is going to be sigma ft over sigma f. Okay, which is going to be 674 divided by 20, and that is equal to 33.7. Is my answer sensible? Well, where would that be? Again, that would be kind of sitting towards the top end of this group here, isn't it? So it's bang in the middle of my data set. Pretty confident that's the right answer. Happy to move on. Question 25. The amount spent on clothes by 40 boys and 40 girls in 1 month were recorded. The table shows information about the amount spent by the boys. Okay, so same old. We're going to do an estimated mean. Going to have to find the mid value first. Halfway between 0 and 20, that's 10. Halfway between 20 and 40, that's 30. Halfway between 40 and 60, that's 50. Halfway between 60 and 80, that is 70. So we're going to multiply those, multiply. So 10 times 22, I can just do it in my head, it's 220. 30 times 9, I can do it in my head, that's 270. 50 times 6, I can do it in my head, that's 300. 70 times 3, I can do that in my head, it's 210. I'm doing very well. I'm just going to add those up with the calculator though. So 220 plus 270 plus 300 plus 210. That comes to 1,000. Spooky. Okay, maybe this came from a non-calculator paper, I'm assuming, because the answers are spookily nice. So anyway, estimated mean for the girls was as a percentage of the... Okay, we need the estimated mean first. I haven't quite read the question yet. There's more to do. Let's find the estimated mean first. Estimated mean. That's equal to sigma fx and sigma f. Who said sigma? That's going to be 1,000 over 40. So 100 divided by 4, that is 25. Okay, does that seem reasonable? Right, it's kind of mid this group here, or towards the lower end of this group here. Okay, but this data is kind of bottom heavy, isn't it? It's quite a lot of people, quite a lot in that first category, which is why the mean is closer to the bottom of the data range than the top. Okay, so we know that the mean for the boys, or the estimated mean for the boys, is 25. We know that the mean for the girls was 35. Estimate the mean of the girls as a percentage of the mean of the boys. Right, so what is the girls as a percentage of the boys? Okay, so girls as a percentage of the boys would be the girls amount, which is 35, as a percentage of the boys amount. So it's going to be 35 over 25 times 100 as a percentage. 35 divided by 25 times 100, that comes about to 140%. Okay, so the girls' mean is 140% of the boys' mean. That makes sense because the girls have got more than the boys. Okay, so 25 times 1.4 is going to give you 35, I guess. Right? Cool. Next up, we're going to be looking at completing the square and turning points. Express x squared minus 6x minus 15 in the form x minus a all squared minus b, where a and b are integers. So the key to this is taking this value here, halving it, and that is going to be this part here then, isn't it? So what we're going to do is going to take 6 and halve it. We're going to get 3. So this is going to be in the form x minus 3 all squared. Now I'm still going to have the minus 15, but I'm also going to get the whatever I put at the end here, I'm going to square it and take away as well. Okay? So it's going to be x minus 3 all squared minus 9 minus 15. So what's that? X minus 3 all squared minus 24. Okay, so that's it. That's my answer. X minus 3 all squared minus 24. Part 27a, write x squared plus 10x plus 28 in the form x plus a all squared plus b, so in complete square form. Again, I'm going to take this coefficient of x, going to halve it. That's the thing that goes in the bracket. X plus 5 all squared. I'm going to take off a square of 5 minus 25, and I'm going to add on the 28 I already had. Okay, so just tidying up that bit at the end, I'm going to get x plus 5 all squared plus 3. Okay, so I suppose a bit right on the answer line. Hence, write down the coordinates of the turning point of the curve x squared plus 10x plus 28. Right, now, these values are at their least when that bracket is 0. And the reason for that is if you square a number, it's always positive. Okay, so the smallest value a square can be is 0. And that value occurs when x is equal to minus 5 in this case, doesn't it? Because minus 5 plus 5 is 0. So minus 5 is the x coordinate. Another way of thinking about it is you just take this number here and you switch the sign and you write it down. That's one way, another way of thinking about it. Okay, so then if that bracket is equal to 0, that bracket will disappear and it'll just leave you with the 3. And then so the 3 is your other value that you need. That's your y value. It's going to be 3. Question 28. The equation of a curve is y is equal to x squared minus 18x plus 70. By completing the square, work out the coordinates of the turning point. You must show your working. Okay, so here's my coefficient of x here. It's minus 18. So I'm going to rewrite this in complete square form. I'm going to say y is equal to x minus 9 all squared minus the square of 9 plus 70. So the square of 9 is going to be 81. So if I take 81 away from 70, that leaves me with minus 11 then, doesn't it? So that's going to be y is equal to x minus 9 all squared minus 11. So the turning point, so then the turning point is going to be when this part of the bracket is going to be 0, and the value of x that makes that bracket 0 is 9. And when that bracket is 0, the y value is going to be minus 11. Question 29a, write x squared plus 6x plus 10 in the form x plus a all squared plus b, so in complete square form. So again, we're going to take this number in front of the x, we're going to halve it, and we're going to write down x plus 3 all squared. That's the square part of it. Remember, we now need to take off the square of 3, which is 9, and then the plus 10 that was already there, we need to add on again at the end. Just tidying that up, x plus 3 all squared minus 9 plus 10 is plus 1, isn't it? Okay, so my answer then is x plus 3 all squared plus 1. Hence, write down the coordinates of the turning point. Okay, so what value of x makes this brackety part 0? Well, it's going to be 0 when x is minus 3. And when that bracket is 0, the y value will be 1. 38, write down x squared plus 8x plus 6 in the form of x plus a all squared plus b, so again in completed square form. So we're going to take this coefficient of x, we're going to halve it, I'm going to write down x plus 4 all squared, subtract the square of 4, which is 16, and plus 6 that was already there, and then tidying that up, x plus 4 all squared, minus 16 plus 6 is minus 10, so that's my complete square form. X plus 4 all squared minus 10. A sketch of the y equals x squared plus cx plus d is shown. The turning point is 4, 7. Work out the values of c and d. Okay, so this one's working backwards then, isn't it? So if that coordinate there is 4 and 7, so remember the completed square form is going to be of the form x minus that number there. So it's going to be x minus 4 inside the bracket, all squared. And then this number here is the bit that you add on the end on the outside of the bracket, plus 7 like that. Okay, so that is the equation of my line, y equals x minus 4 all squared plus 7. But that's the completed square form, and we actually want the expanded form. So I'm going to have to multiply that out and work out what we've got. So x minus 4 all squared, x minus 4, x minus 4 plus 7. So just writing out the double bracket like that. Okay, so we need to multiply this out. So you could use FOIL, first, outside, inside, last, or smile, 2 eyebrows, a nose, and a mouth. Personally, I recommend doing the grid. How many times I've marked a paper and someone's lost a term in an exam because they're rushing and they forget. But if you do the grid, you know you've got a place for each of the 4 values and you won't forget. So x times x is x squared, x times minus 4 is minus 4x, x times minus 4 is minus 4x, and minus 4 times minus 4 is plus 16. Okay, so doing the grid method, this value here is our term in x squared. And then we've got 2 terms in x along this diagonal, minus 4x and minus 4x makes minus 8x, and then I've got 16 on the end, plus 16. Okay, remember I had that plus 7 from earlier, so then just tidying that up, x squared minus 8x plus 16 plus 20 plus 7 is going to be plus 23 then, isn't it? Okay, so then what is the value of cx and d? Well, cx is the coefficient of x, or c is the coefficient of x, which is minus 8, and d is the constant on the end, isn't it, which is plus 23. Okay, so they're my values of c and d. So c is minus 8 and d is 23. Question 31a, show that x squared minus 8x plus 20 can be written in the form x minus a all squared plus a. Okay, interesting, double a. Right, so let's do that then. So taking the coefficient of x and halving it, so I'm going to get x minus 4 all squared, taking off a square of that number, minus 16, plus the 20 that was already there. That's going to give me x minus 4 all squared plus 4. Yeah, so a and a then, isn't it? So we did it. Hence explain how you know that x squared minus 8x plus 20 is always positive. Okay, so turning point is, well, it's going to be the value of x that makes that bracket 0, which is 4. And when it is equal to 0, the y value is going to be 4. So the turning point is at 4, 4. And this is a smiley parabola, isn't it? So it's going to look like, if you think about a graph, if you think about the point 4, 4, then the graph is going to be a parabola through that point, isn't it? And you can see that it's always above the x-axis. So we can say that the entire curve lies above the x-axis, hence y is greater than or equal to 0 for all values of x. Okay, next up we've got cumulative frequency. So so we need to know how to find cumulative frequency from a frequency table, and we need to know how to draw a cumulative frequency curve. Okay, so first up, how do you find cumulative frequency? Well, that's pretty easy. So cumulative frequency, the first cumulative frequency is just the same as our first frequency, and then our next cumulative frequency, cumulative means adding on to. It means you keep adding on to as you go along. So the second cumulative frequency is going to be the 0 plus the 12, which comes to 12. The third cumulative frequency is going to be 0 plus the 12 plus the 38, which adds up to 50. The next cumulative frequency adds on the 36, so I can add the four numbers together. I can just add 36 onto the 50. That's the same thing, because 50 is the first three numbers. So you can just add your new frequency to your old cumulative frequency as you go down the list. So 50 plus 36 is 86. Next one is going to be 86 plus 24. That comes to 110. And then I've got 120 on the end. Always good to check that it's equal to the total. Normally it tells you in the question, this doesn't, but this one, it normally says what it's out of, so it'll often say it up here. This one doesn't. It should still be the same as what the whole list adds up to. So you could check it that way as well. All right. Now, once we've got the cumulative frequencies, we can then plot them on a cumulative frequency curve. Now, we plot cumulative frequency on one axis, so you can see cumulative frequency here, so that's those. And then the bottom axis is going to be, we always use the upper limit of these, so we plot against upper class bound. Not the median, not the low one, but the upper class bound. Always plot against those. Plus we've got a bonus point we can plot here at this first value of your cumulative frequency plus you've got this extra bonus point that you can plot at the lower bound of the first group on your cumulative frequency table. Okay, so I'm going to plot a point at 0, 0 as a bit of a bonus point. There's that one there. Now the next point is going to be at but then the next one is at 0 as well. So normally you would plot that one, but this one is 0 anyway. So my graph is actually starting there, isn't it? Okay. And then at 100, I'm going to be plotting 12. Now you can see there are 5 little divisions between 0 and 10 here. So each one of those is going to be 10 divided by 5. It's going to be worth 2. So if I want 12, it's going to be one little square above 10, isn't it? So at 100, I'm going to go up to one little square above 10, which is there. The next one is at 50. That one should be fairly easy to plot against 120. So 50 is going to be here. The next one, 86. That's going to be 3 little squares above 80. So where's 80? And then count up 3 more little squares. 1, 2, 3. It's going to be there. And then the next one is at 110. It should be fairly easy to plot again. So a major line there. And then finally at 120. Okay. Now the shape of these is a kind of an S-shaped curve. The gradient should kind of start flat. So when you're joining these, you kind of start from a flat line, and then you go through that first point. Try and skew at each one of your points. Single curve, and then it flattens out at the top. So the gradient should kind of go flat again at the top like that. All right. So yeah, it has this distinctive S-shaped curve that you get. And then part B says, estimate the number of these films with a running time of less than 130 minutes. Okay, so we're going to find 130 minutes on our scale. 130 is going to be halfway between 120 and 140, isn't it? It's going to be here. Okay, so reading up with my ruler from that little mark up to the line. It's good to show method by drawing this line on. Okay, when you get to the curve, change direction. And that's going to be my answer here. Now I think that's pointing to 70 on mine. Now yours might vary slightly to mine. It's not an exact science drawing a cumulative frequency curve. You do get a bit of variation from graph to graph. So as long as you write down the number on your graph, you'll do fine, you'll get the mark. So estimate the number of these films with a running time of less than 130 minutes. Now when you look at the cumulative frequency, it tells you the number of people with that amount or less. So this is going to be 120 or less. 70 people with 120 or less. Next up, we've got two columns here. Normally this first one is another way to write down t. Normally you write down the right hand limit here. Remember I was saying that we just use the upper hand limit for these. So normally if they give you two columns, they're expecting you to put that upper hand limit in. Okay, and then this is going to be the cumulative frequency here. So the number less than 20 is just the first answer is 21. Then the next one is going to be 21 and 30, that's 51. The next one is going to be 51 and 19, that's 70. And then adding on 10, that's 80. I was saying before, you can then usually just check that against what's in the question up here, because it's usually written there, so you can usually use that to check your work. Okay, right, so then we're going to be plotting the right hand limit, the upper class bound, which we wrote down here again here, against cumulative frequency, aren't we? So and remember we've got a bonus point we can plot here, so 0 against 0. So I'm going to put my first point here at 0, 0. Next one is going to be at 20, at a height of 21. Now again, I've got 5 little squares between 10 here, so each square is worth 2. So if I want 21, then we're talking about half a square then, aren't we? So half a square above 20 is 21. 51, that's going to be half a square above 50. And next one, 60 versus 70. And then 90 versus 80. Okay, so once you've plotted your points, remember the gradient kind of starts 0-ish, like that, kind of curves up like that. Just skew each one of your points in a nice, smooth, continuous line. And again, remember the gradient kind of tops out at that top volume there, so it should kind of end at a kind of a flat rate like that. It should be like an S-shaped curve through your points. Okay. Right, do we got any questions on this one? Estimate the percentage of teachers who took over 45 minutes to travel to work. Okay, so again, we're going to start off the same way. We're going to find 45 minutes on the x-axis or the time axis. It's going to be halfway between 40 and 50. Going to use our ruler to measure up to the line. So you're using a little dotted line to show some method. Let's get rid of that. So I'm reading that as coming off at about 3 squares above 50, so that's like 56, isn't it? Okay. Now, but remember what I was saying earlier. What this graph is telling you is that that below 45 there are 56. All these people, all these 56, have got a time of 45 or less. Now we want people who took over 45 minutes. Okay, so over 45 minutes is this side of the line, and it's going to be on the cumulative frequency, it's going to be these people up here. Okay, so if 56 people took 45 minutes or fewer, then it's going to be 80 minus 56. That's 24, isn't it? So this section here is worth 24 people. So there are actually 24 people who took more than or 24 teachers who took more than 45 minutes to travel to work. That's a very long time to travel to work. Teachers, go and live a bit close to your school. So 24 teachers. I think it wants us in a percentage sort of form here. Estimate the percentage of teachers. So if there are 24 teachers and there are 80 teachers altogether, so the percentage is going to be 24 over 80. Then is it written as a percentage? What's that then? 24 over 80 times 100. 24 divided by 80 times 100. I make that 30. That's 30%. Okay. Question 34. Here's some information about miles per gallon of 60 cars. Okay, so then this is going to be our x value again, and this is going to be cumulative frequency. Expect us to write this part in here. So less than or equal to 50, less than or equal to 60, less than or equal to 70, less than or equal to 80. So it's the upper bound. And then cumulative frequency, the first cumulative frequency is the same as the frequency. Next one is going to be the first two added together, that's 22. Next one is going to be 22 and 28. That adds up to 50, and plus 10 is 60. Just check this gives you the same number as in the question. It does. And so then we can go ahead and plot these points then, can't we? Don't forget you can plot a bonus point down here at 40 and 0. So I'm going to have like a 0 point at 40 there. And then my first point is going to be 50 and 6. So again, I've got 5 squares representing 10. So each little square is going to represent 2. So 6 is going to be 3 squares above 0. Then 22, that's going to be 1 square above 20. 50, should be a nice easy point to plot there. And then at 80, I've got 60. Should be a nice easy point to plot there as well. Okay, when you're drawing your cumulative frequency curve, remember the gradient kind of starts off flat and then kind of curves around through your first point. Try and draw a nice smooth line through each of your points. And then your gradient kind of tops out at that top value, so you should kind of curve back down to 0 when it hits the last point like that. All right, so there's my curve. It looks pretty good. What's the question they're going to ask me about it? Use your graph to work out the interquartile range. Okay, so the interquartile range, that is Q3 minus Q1, the upper quartile minus the lower quartile. Now the upper quartile occurs 3/4 of the way through your data, and the lower quartile occurs 1/4 of the way through the data. Now we've got 60 values altogether, so if I take 60 and divide it by 4, I get 15. Okay. Now really when you're finding quartiles, you're meant to add 1 before you divide, but when your number of values is large, like 60, adding 1 doesn't really make much difference. If you add 1 and divide by 4, you're going to get 15 and a quarter. But you know, what you look up at 15 and a quarter versus what you look up at 15 doesn't make any difference on a graph like this. So you just kind of use 15, just divide it by 4, it's good enough. Okay, you're not going to get any more accurate a lookup on your graph anyway. So reading across from 15 till we get to the curve, and then switching directions and going down, that's going to give me my lower quartile. I make that 50, 56. Okay, so that's my Q1. 56, that's Q1 there. Right, and then Q3, the upper quartile, is 3/4 of the way through. Now again, you should really add 1 when you find an upper quartile, but when you've got a large number of data points, then it doesn't really make much difference. So I'm just going to divide by 4 and times by 3. So 3 lots of 15, that's 45. So I'm going to look across at 45. And down. And that's going to be my Q3 value there. I make that about 68 on my graph. Now if yours is a little bit different from mine, don't really worry about it. As long as you read your graph, your values off your graph, you're going to get the marks for this. So 68 minus 56, that leaves me with 13. So that's my interquartile range. Use your graph to work out the interquartile range. It's 13 miles per gallon. Question 35. The cumulative frequency graph represents the masses of 40 necklaces. A jeweler buys every necklace with a mass greater than 21 grams. Use the graph to estimate how many she buys. Okay. So we're going to look up 21 on our graph. Where is 21 on the mass scale? We've got 5 digits, 5 units between 20 and 25. So it's just going to be 1 square over from 20, isn't it? So reading up from there up to I hit the curve. Okay, and then change direction. So I make that like 1 little square above 15. Again, there are 5 divisions on this. Again, there are 5 units between 15 and 20 and 5 little boxes. So each one of those must be 1. So I'm reading that off as 16. Remember, what this is telling you is that there are 16, what are they? 16 necklaces that are 21 grams or less. We want the number of necklaces that are greater than 21. So we want these ones up here. Okay, now my graph goes up to 40. So what's the difference between 40 and 16? 40 minus 16, that's 24. So they're going to be 24 necklaces that have a weight greater than 21 grams. Now part B says the lowest mass was 3 grams, the highest mass was 28 grams. Draw a box plot to represent the data. Okay, now for a box plot we need 5 value. We need the lowest value, which we've got, which is 3. We need Q1, we need Q2, we need Q3, and we need the highest value, which we know is 28. Now, we don't currently know Q1, Q2, and Q3, but we can easily read those off our graph. Okay, so coming back to the graph, we need to find the lower quartile, the median, and the upper quartile, Q1, Q2, Q3. So I'm going to take my number of values, 40. The lower quartile is going to be a quarter of the way through. That's going to be 40 divided by 4 is 10. So I'm going to have a line at 10. Okay, I'm going to have one halfway through for the median, Q2. And I'm going to have one 3/4 of the way through. That's going to be 30, isn't it? That's going to be Q3. Okay, it's easier for me to draw all 3 lines and then wiggle my ruler around. Draw them back down again. So there's one there, one there, one here. So that's Q1 there. So that is 16. That's Q2, the median, which is at 22. And then Q3 is here, which is at 24. So 16, 22. So 18, 22, and 24. So I've got Q1 at 18. Q2 at 22 and Q3 at 24. Okay, so then once I've got all my values, I can then draw the box plot then. Okay, so I'm going to have a line at 3. So I'm going to draw a line at 3. I'm going to draw a line at 18. I'm going to draw a line at 22. And a line at 24, and finally a higher value at 28. Right, so then once I've drawn those 5 lines, I'm going to just do some extra lines in here. Now you're going to have a box between around the Q1 up to Q3 where the word box plot comes from. So that's the box from the box plot. Now these diagrams are actually, proper name for them is box and whisker diagrams. Okay, so that's the box of the box and whisker diagram. And then the whiskers reach out from the box out to your highest and lowest values. I don't know why exam boards just call them boringly box plots and neglect the whiskers. I think box and whisker diagram is much more descriptive of what we've got here. Yeah, so that's my box and whisker or box plot. Okay, so you've got your box around Q1 to Q3 with your Q2 line in the middle and the whiskers reaching up and down to your lowest and your highest value. Okay. Next up, histograms. Now, a histogram is not a bar chart. Bar charts are used for discrete data. So you'll have bars like this. They're all the same width and there is a gap in between them. Okay. Histograms are not bar charts for a number of reasons. Firstly, this is not frequency, as it is on bar charts. It's frequency density. The other thing is there's no gap between the bars like you do have on bar charts. There's no gap because histograms are used for continuous data. These are for discrete. These are for discrete data. That means whole number values or part number values, but certainly not all the numbers in between. But these are for continuous data. So think about time or distance and things like that, what they're used for. Okay, so that's another difference between them. And the other thing is, of course, that the bars are different widths depending on the groups that they represent. The other thing about bar charts is that it's the height of the bar that's important, and that tells you the frequency. With a histogram, it's the area of the bar that tells you the frequency. Okay, so estimate the number of students who took less than 85 seconds to complete the puzzle. So 85 is kind of smack bang halfway between the tallest bar there, isn't it? So I'm going to divide this bar in two. Yeah, 85. So we're talking there. Okay, so what we want is we want all of the bars to the left of that cut-off line. They're the ones who took less than 85 seconds. So all of these guys took less than 85. These guys took less than 85, plus the left-hand side of this bar took 85. Okay, now remember me saying a while ago that it's the area of the bars that represents the frequency. So what we'll need to do is to find the area of these three bars and then add it up. Oh, where did my nice shading go? Come back. Right, so let's find the area of these bars. Well, luckily they're quite easy to find because they're all rectangles. It's super easy to find the area of a rectangle. So the area of this rectangle is going to be length times width. So that's 0.3 times 40 to 70 is a distance of 30, isn't it? So what's 0.3 times 30? That's going to be 9, I believe. That represents 9 people. This next bar is 10 times 0.6. So that represents 6 people. This next bar is 5, very skinny, times, how far does it go? Up to 1. Okay, so that represents 5 people. Okay, so then to find the total number, we're just going to add those 3 numbers together. I'm going to add the 9, the 6, and the 5 together. So then it's going to be 9 plus 6 plus 5. That adds up to 20. My answer is 20. Question 37, it actually wants us to draw a histogram. Now it's got 2 extra columns added to the data table for us to do some calculating. Now the best things to use these for is the class width and the frequency density. Okay, so I'm going to do class width first. So the class width is just how wide each of the groups are. So from 0 to 5, 5 take away 0 is 5. That's a class width of 5. Next one, 5 to 10, 10 take away 5 is 5 as well. The next class width, 10 take away 20 is 10. And the last one, 50 take away 20 is 30. They're all the class widths. And then frequency density, that's equal to frequency divided by class width. That's the formula for it that you need. Okay, so frequency density is frequency divided by class width. So basically you're dividing these, aren't you? 18 divided by 5, 23 divided by 5, 17 divided by 10, 21 divided by 30. Right, so 18 divided by 5, divided by 5, double it and divide by 10 is the easiest way. So 18 times 2 is 36, divided by 10 is 3.6. Same thing with 23, double it is 46, divided by 2 is 4.6. 17 divided by 10, that's pretty easy, it's 1.7. And then 21 divided by 30. Well, divide it by 3 first, it will be 7. Divided by 10, it will be 0.7. Okay, so they're my frequency densities. So now I'm ready to draw my bars. I'm going to cheat and use the bar drawing tool. So 0 to 5, height of 3.6. And we're going to draw a square from 0 to 5, height of 3.6. So next bar goes from 5 to 10 with a height of 4.6. Then we've got 10 to 20 with a height of 1.7. And then finally 20 to 50 with a height of 0.7. Okay, I'm happy with my histogram. Looks pretty good. Question 38. The histogram shows the time it takes 270 students to travel to school. Kirsty says 30% of the students take more than 25 minutes to travel to school. Is she correct? Use your histogram to decide. You must show your working. Right, so 30% of the students take more than 25 minutes to travel to school. So we're going to test that. we're going to find out how many people we think take more than 25 minutes to travel to school and compare it with Kirsty's 30%. Okay, so what we're going to do, we're going to find 25 minutes on the graph, and we're going to draw a line. So it's a little bit like the first question, in that we're then going to have to work out the area of the bit to the right of that line then, aren't we? Okay, so we need to find this area, this part of this bar, and then the area of this bar here. Okay, and then add it together. That should be the number of people who took 25 minutes or more to travel to school, and then we can work that out as a percentage of the total. Right, so the first bar, that has got a width of 5 and a height of, what's that, 6? Just double check that is 6. Yes, it looks like 6. So that's going to be a height of 6. So 5 times 6, that's 30. And then the other bar has got a width of 20 and a height of, seems to be exactly 2. 20 times 2, so that represents 40 people there. Okay, so we got 30 and 40, so number of students, it's going to be 30 plus 40 from the 2 bars, that's 70. So what is that as a percentage? Now we've got 270 students in total, so expressing 70 as a percentage of 270, so the percentage is going to be 70 over 270. You should express it as a fraction first, and then you times it by 100, and then you're going to get it as a percentage then, aren't you? So 70 divided by 270 times 100, that gives you 25.925 reoccurring. I'm just going to round it off to 25.9%, let's say. So remember, we need to answer the question. The answer is not 25.9%. The question was, is she correct? And the answer is no. Okay, because it's not 30%. It's 25.9. Okay, question 39. Here's some information about the ages of people at a concert. We've got a group frequency table, and we need to draw a histogram from it. Now this time they haven't been kind and given us the columns to draw them in, but you know, we've got a ruler, we can make our own boxes. It's not that hard, is it? So just kind of make some extra columns and things to put your information in. Right, so then let's work this out. So this is going to be class width, and this is going to be frequency density, like before. Okay, so class width from 10 to 15, that's got a class width of 5. 15 to 25, that's 10. 25 to 40, that's 15. And from 40 to 70, that's 30. Frequency density then, 8 divided by 5. Double it divided by 10 is 1.6. 24 divided by 10, that's 2.4. 30 divided by 15, well, I know that, it's just 2. And then 39 divided by 30, well, 39 divided by 3 would be 13. And then divided by 10, it'd be 1.3. Okay, so I've got all my frequency densities. Can go ahead and start drawing them now, or cheating and getting the computer to draw nice boxes for me. Right, so the first box goes from 10 to 15 and has a height of 1.6. So 10 to 15, height of 1.6. This computer is so bad at drawing these boxes. I think I've got that scale wrong. So there are actually 10 divisions between, I thought that was 1 and 2 then when I drew it. So 1.6, that's not right, is it? It's going to be, if that's 1.5 and that's 2, that means I've got 10 little boxes between 1.5 and 2. That means each one of these boxes is 0.05. So 1.6 is going to be 2 little boxes above 1.5, then it's going to be there. Okay. Then the next one, which is at 2.4, that's going to be 2 little boxes below 2.5 then, isn't it? So if I start from there and I draw down, so from 15 to 25, a height of 2.4, that looks good. And then 2, that's a little bit easier to draw. I think I can manage that. Right, there we go. Where's that going from? That's going from 25 to 40. So this wide. And then finally 1.3 width of 30 from 40 up to 70. So 1.3 is going to be 6 little squares above 1. Yeah, so that's how I'm going to draw mine. Next up, we've got advanced trigonometry. What I mean by this is non-right angled trigonometry. You've got 3 things that crop up in this section. So you've got the sine rule. A over sine A equals B over sine B equals C over sine C. Or the other way around, depending if you're finding the sides or the angles. You have got the cosine rule. C squared equals A squared plus B squared minus 2AB cos C. Or you might need to reformulate it depending on which sort of triangle you've got. And then you've got the trigonometric version of the area of a triangle formula, which is area equals half AB sine C. So you need to know how to use each of those 3. Most important thing really is to spot when to use the sine rule and the cosine rule. So we'll be looking at how to choose between them as we go through these questions. Okay. So just a slight difference between non-right angled trigonometry and right angled trigonometry. With a right angle triangle, you only need to know 2 other things, don't you? You need a side and an angle to use one of the trigonometric ratios, or you need 2 sides to use Pythagoras theorem. With the sine rule and the cosine rule, and with the area formula, you need to know 3 things. Okay, so it's not 2 is not good enough. You need to know a 3rd thing to be able to use these rules. So you need to know 3 things to find a 4th thing. And you can see that in this question here, they've given us 3 things, 1, 2, 3, and we're using it to find a 4th thing. Okay, so 3 things to find 4 things in non-right angle triangles, 2 things to find the 3rd thing in a right angle triangle. Okay, now first up, I've got a non-right angle triangle then, and I want to find a side given that combination of angles and sides. Okay, so I've got enough things, I've got 3 bits of information, so I should be able to find a 4th thing. But am I going to use the sine rule or am I going to use the cosine rule here? Now, the way that I think about it is that the sine rule is about opposites. It's about opposite pairs. And the cosine rule is about 3 sides. Either you've been given 3 sides and you want an angle, or you've been given 2 sides and an angle and you want to find a 3rd side. Now, what have we got here? Have I got 3 sides or have I got opposite pairs? Okay, well, I've only got 1 side and I want to find the other side, so immediately I'm thinking this is not the cosine rule, because if it was the cosine rule, I would know this number here. There'd be a number here and I'd be able to then go on and find y. It isn't, so it's not going to be the cosine rule. What you've got here is opposite pairs. You've got an angle here, which you know, and you've got the side opposite, which you know. You've got an angle here, which you know, and you've got a side opposite which you'll want to find out. Okay, so with the sine rule, you're always going to have opposite pairs like that. Okay, so I've got a 70 going with the 15, I've got a 35 going with the thing that I want to find. Okay, now the sine rule you can write down either with the angles on the top or the sides on the top. Now I would write it down in the way that you want to find it. So if I want to find the side, I'm going to write it down with the sides on the top. If I want to find an angle, I'm going to write it down with the angles on the top. Okay, now there's no letters on here, so you can do it yourself. I'm going to label this one A, angle A, side A. This one is angle B, side B. So you always label opposite sides and angles with the same letter. Use a capital letter for the angle and a lowercase letter for the side. That's how all of the sine rule and cosine rule rules are written. So if you follow that, when you label up your sides, you'll be able to substitute much more easily into the sine rule and the cosine rule. Okay, so I'm going to start with the sides on the top. So I've got A over sine A is equal to B over sine B. Now you'll see there's 4 things here. I know 3 of the things. I want to find the 4th thing. Okay, so sub in what I know. A is 15. Sine A is sine of 70. B is the thing I want to find, and sine B, that is sine 35, isn't it? Okay, so sub into the sine rule. Next thing is to rearrange the sine rule to get the thing you want to find on its own. So I'm going to move that up here. Okay, now because I put b at the top to start with, that makes the rearrangement a little bit easier. So then b is going to be equal to 15 sine 35 over sine 70. Okay, so then it's just a matter of typing it into the calculator. So then 15 sine 35, just take care with brackets here. It's one of those cases where it may well matter if you put brackets in the right place or not, divided by sine 70. It doesn't really matter with right angle one, it usually works it out anyway, but put brackets in here because they're a bit more complicated. Now that comes out to be 9.155. Generally go to 3 significant figures unless it tells me otherwise, or 1 decimal place for angles. So I'm going to write down 9.16, round it up, 9.16 there. It's 9.16. Question 41, use the sine rule to work out the size of angle X. So here we, again, what if we got 3 sides here? No, we don't. Look, we don't have anything here. So it's not going to be the cosine rule. So next, look for opposite pairs. Now I've got 64 matching up with 23, and I've got my unknown angle here which matches up with the side that I know. So again, this is an example of where we're going to be using the sine rule. Okay, so again, I'm going to label up my sides, capital A, lowercase a, capital B, lowercase b. All right, see there, b. And then I'm going to write down the sine rule, but this time I'm going to write it down the other way up. Because I want to find an angle this time, I'm going to write it down with the angles at the top and the sine and the sides underneath. So rather than writing a over sine a, I'm just going to flip it over and write sine a over a equals sine b over b. Now in the formula book you've got 3 parts of the sine rule. You never use 3 parts of the sine rule. You only ever use 2 bits of it. Okay, so you pick out the bits that you need. You're only ever going to use 2 parts. Never going to use 3. Hard to have an equation with 2 equal sides. Doesn't work. Right, so then once we've written it down, sub in. So I've got sine, I'm going to substitute back into for x now. So sine x over a, which is 17, is equal to sine b, which is 64, over b, which is 23. Okay, need to get x by itself. Let's just cross multiply that 17 over to the other side. I'm going to get sine x equals 17 sine 64 over 23. So then x is going to be the inverse sine of that then, isn't it? 17 sine 64 over 23. Okay, and that's what I'm going to type into the calculator. So shift sine 17 sine 64 over 23. Just close bracket, okay, make sure I put the brackets in the right place, I think. And that comes out to be 41.6 degrees to 3 significant figures, or 1 decimal place. So 41.6. Question 42, here is a triangle. So work out the length of PR. So PR, where's PR? It's this side here, isn't it? That's the one we want to find. Now we've already got 2 other sides, and now look, we're looking for a 3rd side. So this triangle, and this question is about 3 sides. So this one is the cosine rule, okay? And we need to work out that length, PR. With non-right angle triangles, we label opposite sides opposite to their letter. So if it's capital Q on that side, we're actually trying to find side little q over there. If it's capital R over here, then this is side little r. And if that's capital P, this is the sine little p. Okay. Now, you need to be able to take your cosine rule in the form that is given on your formula sheet. I think it starts with an a squared equals b squared plus c squared minus 2bc cos a, I believe, on the formula sheet. Just doing this off the top of my head. But you need to be able to reformulate that into the form of letters that you've got on your diagram. Alternatively, you can just scratch them all out and label them up with the letters that you have in the diagram. That's another way of doing it, and then you don't have to change anything. Now I don't like getting my diagram all messy like that, but you can do that. You can literally just cross it out right A and cross it out right B and just label it up the same way it is in the formula book, but you know, amateurish. So I'm not going to do that. I'm just going to reorganize the cosine rule for the letters I've got. Okay, so now I'm going to start off with the letter I want, q squared. It's a little bit like Pythagoras. It starts off like Pythagoras theorem. So it's q squared equals r squared plus p squared. And then we've got minus, and then the two letters you just wrote down, you're going to have minus 2 of those, 2rp, and then cosine of the angle that you, the same letter as the letter you started with, so it's cos q. So I kind of remember the pattern, okay? So the front one and the back one match, and these two match these two here. That's how I remember it, okay? So then I can reformulate it pretty easy for whatever 3 letters I've been given, okay? Now, as I say, if you struggle to do that, then you can just relabel your diagram with A, B, and C, and then just use the form that they give you. Okay, but I prefer to just reformulate into the triangle that I've got. Then I can substrate in, so R is 6, so that's 6 squared plus P squared, which is 9 squared, minus 2, lots of 6, lots of 9, cos Q, which is 120. Okay, right, so what's that then? Now, there's quite a lot to type into your calculator. Now, you can type it all in straight away, okay? I tend to like to do the easy bits of the maths in my head because I know I'm better at working out basic maths than I am at typing things accurately into the calculator. I make more key and errors on the calculator than I do by multiplying simple numbers together because I've been practicing for many years. So for instance, I'm not going to make a mistake with 6 squared. I know it's 36. I know 9 squared is 81. I know that 2 times 6 times 9, 6 nines I know is 54, double is 108. So you know, this is not complicated maths for me. I can just write it down really quick. Whereas if I was keying all that into the calculator, I could easily make a key in error. Okay, so I'm more confident with my mental maths than I am with my tappity-tap skills. Right, so 36 plus 81, that's 117. Okay, so it's 117 minus 108 cos 120. Now, when I get into this form, that's when I type it into the calculator, making a little bit of the keying in easier than it would otherwise be. So 117 minus 108 cos 120, and that comes out to be 171. Now that looks quite big, but remember that's q squared. So if I want q, so q squared is 171. You know, if you had 171 on that diagram, that triangle was never going to meet up, is it? So 6, 9, and 171, that's definitely not right. So just root that as your answer before you write down your final answer. That comes to 3 root 19 or 13.07. I'm going to round it off to 13.1. So Q equals 13.1. That's my final answer, 13.1. Question 43, work out the size of angle X. Now, this is a find an angle question, but notice again, we've been given 3 sides, 14, 25, 36. 3 sides, going to be the cosine rule. Okay, so let's label up our sides. A is opposite A, so that's a little A there. C is opposite C, B is opposite B. We want to find the angle at A. So I'm going to start off with the cosine rule that starts with A. So A squared equals B squared plus C squared minus 2BC cos A. So notice I start and end with the same letter, and these ones are repeated here, 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 and here. Okay? So that's the pattern of the cosine rule. Now this time, it's this thing on the end that I want to find, which is kind of embedded on the right-hand side. So I've got a bit of rearranging to do here. Okay, so add in 2BC cos A to the other to both sides, or shifting this whole bit over to here and shifting this bit over to here. I'm going to rewrite this as 2BC cos A is equal to B squared plus C squared minus A squared. And then finally, dividing through by 2BC, I'm going to get cos A is equal to B squared plus C squared minus A squared over 2BC. Okay? Now, once I got it written like that, then I can sub into it, can't I? So cos A is x, that's the thing I want to find. B squared, 14 squared. C squared, 25 squared. A squared, minus 36 squared, over 2 B, 14, C, 25. Okay, so I could type all that in one go, I think, into the calculator. So let's get the fraction key up. Actually, we want the inverse cosine of this as well, don't we? So x is equal to, so we're going to use shift cos, okay, and then I'm going to put the fraction key, so I've got like a numerator and denominator to fill out. And I'm going to do 14 squared plus 25 squared minus 36 squared on the top. I don't know 14, 25 and 36 squared off the top of my head, so that's why I'm not bothering to do what I did earlier and simplify it. So 2 times 14 times 25 on the bottom. Just going to come out of that and close the bracket. Probably doesn't make any difference, but hey ho. Right, now press the go button. That comes out to be an angle of 132.7. Does that look right? Well, I've got an obtuse angle, and 132.7 is definitely obtuse. So, yeah, I'm feeling good about that. I'm feeling all right. 132.7 looks good. So let's write that one in. 132.7. But yeah, always imagine your number on your diagram before you move on and say, well, does that sit right on my diagram? And yeah, 132.7 kind of matches that picture. So, you know, they're not drawn accurately, so it's not going to be a 100% guarantee you're right or wrong. But, you know, if it looks right, it's probably... But if it looks wrong, it's probably going to be wrong, and you can go away and check it in the exam rather than waiting for your results to come back to find out it's wrong. Question 44, work out the area of the triangle. So now we're going to be using our trigonometric area formula. It says area of a triangle is half AB sine C. Now to find the area of a triangle using trigonometry, you need two sides and the included angle. It's always the angle between the two sides that you know, and that's what I've been given here. I know this side, I know this side, and I know that angle between them. So I can use the formula here. If you think about it, if this was angle C, then these two would be A and B, and so this would be A and this would be B. So I would have A, B, and sine C. Okay, so it has to be the two sides and the angle between them that is the one you want. Okay, so here I'm going to get area equals a half times A, which is 12, times B, which is 8.4, times the sine of C, which is 49. Okay, right, so I might just halve that and get 6, just to make things a little bit easier to type in. So 6 times 8.4 times the sine of 49. That is 38.0. Okay, so that's my answer, 38.0 centimeters squared, I guess. Question 45, the diagram shows the sector of a circle, center O, radius 18. Work out the area of the shaded segment. Okay. Now, these are actually quite typical setups for an exam question, and it involves you knowing how to do two things. Thing one is you need to find the area of a sector. So I need to find the area of the sector AOB of the sector, and I need to be able to find the area of the triangle. So I can take area of triangle away from area of sector, leaving area of segment. Okay? They're the two things that I need to know how to do. Okay. Now the area of a sector is just a fraction of an area of the circle, isn't it? Now I know the area of a circle is pi r squared. Cherry pie delicious. Apple pies are 2. So pi r squared is the area of a circle. But we haven't got a whole circle. We've got a fraction of a circle. So my whole circle will be like this. We've got 40 360ths of a circle. So that's my fraction I'm going to use. I'm going to use 40 360ths of a circle, and that's going to be the area of my sector then, isn't it? Okay, So 40 360ths of pi r squared, where r is the radius, it's 18. Okay, so that's going to be, well, 40 over 30, 360. I'm just going to cancel that down a little bit. So that's 436. Dividing top and bottom by 4. So that's 1/9. It's a ninth of the, so that's a ninth times pi times 18 squared. Okay, so what's that then? 18 squared, I'm just going to leave it in terms of pi, so I'm just going to do 18 squared divided by 9 for now. I'm just going to leave it in terms of pi. Okay, so that's 36 pi. There's no point in evaluating it now. I just have a horrible decimal there rather than a lovely thing with a pi in it. Okay, I can then put the whole exact value for the area of a sector into my final calculation rather than writing down a horrible decimal. Right, so then I've got 36 pi for the area of the sector. Now the area of the triangle, I'm going to use the trigonometric area formula, half AB sine C, aren't I? So half AB sine C. So remember, it's the two sides that you know and the included angle. So I've got that one marked at 18, but this one is also a radius, so that's also 18. So these are the two sides that I know, look, and the 40 is the included angle. So I'm good to use the rule. I'm going to just go straight away and plug those in. So it's half of 18 times 18 times the sine of 40. Okay? So probably just going to cancel that into that, give me 9, and make it slightly easier to type into the calculator. 9 times 18 times the sine of 40, that comes out to be 104.1. Okay, so now I've got those two, I can say that the area of the segment is going to be the area of the sector minus the area of the triangle. Okay, so that's going to be 36 pi minus 104.1. Okay, now 104.1, I've still got the exact value on my calculator, and 36 pi, because I left it in terms of pi, is also an exact value, so I'm going to get a super accurate answer, aren't I? If you round it off, you always move away from the true answer. So I'm going to do 36 pi minus answer, and that comes out to be 8.965. I'm going to round up to 8.97. So that is equal to 8.97, and that's going to be my final answer then. It's going to be 8.97 square centimeters. Next up, we've got straight line graphs. What do we need to know about this? Well, we need to know about y equals mx plus c, the general form of a straight line graph. You need to be able to find m and c from a graph. M is going to be y2 minus y1 over x2 minus x1. If you've got coordinates, that's a nice way of working it out. C is going to be your y-intercept. So you should be able to find that from a graph. You should be able to find m from two coordinates, or it might be given to you. What else do you need to know how to do? You need to know about perpendicular lines, that are lines at right angles. So if one has a gradient of m, the other one is the negative reciprocal, it's minus 1 over m. So that's a useful bit of information to know about this. There's a few other bits and bobs that we need to know, but I'm sure they'll come up in the course of the questions. So let's just crack on and start with this then. So question 46, work out the gradient of the straight line y equals minus 3x plus 1 is equal to 0. Now that does not look like what I just wrote down, y equals mx plus c, but we can make it look more like that by just moving bits of it over the equal sign. So if I take the minus 3x and move it over, and the plus 1 and move it over, I'm going to get y is equal to, it's going to be positive 3x if I move it over the equal sign, minus 1. Okay, now it looks like y equals mx plus c, where m is 3, look, and c is minus 1. So what is the gradient of this straight line? It's going to be 3, isn't it? Question 47, work out the equation of the line that is parallel to the line y equals 4x minus 1 and passes through minus 1, 1. Okay, well if it's parallel, It's going in the same direction, and if it's going in the same direction, it has the same gradient. So my new line is going to have the same gradient as the old line. So m is going to be 4. So then the equation is going to be of form y equals 4x plus c, where c is the y-intercept. Now how can we find c? Well, easily enough, we can just take this coordinate and we can sub it in for y and x, and then the only thing we won't know is c in that particular substitution. So we can then equate c to whatever's left over, and that will be our value of c. So let's sub in -1 for x and 1 for y. We're going to get 1 is equal to 4 lots of -1 plus c. Okay, so 1 equals -4 plus c. That tells me that c is going to have to be equal to 5. And so the equation of this line is going to be y is equal to 4x, because we already had that part, plus 5, the y-intercept. So we knew that the gradient was 4, got it from up there, and we've now worked out that c is 5, we got it from there. Okay. Question 48, line A has the equation y equals 4x minus 1. Line B is perpendicular to line A and passes through the point 8, 5. Okay. So our original line has gradient of 4. So that's m1. m1 is equal to 4. Now what's m2, the gradient of our new line? m2 is going to be the negative reciprocal of m1. So it's going to be -1 over 4. Okay, that's the gradient of my new line. So the equation is going to be of the form y equals m, where m is -1/4 of x plus our y-intercept c. Okay. Now we know it passes through the point 8, 5, so we can say passes through 8, 5. So subbing that in for y and x, then I'm going to get 5 is equal to -1/4 lots of 8 plus c. Okay, well that's 5 is equal to -1/4 lots of 8 is -2. So rearranging for c is equal to 7 then, isn't it? So now I know the gradient, it's -1/4, and I know c, it's 7. So piecing that together, my equation is y is equal to -1/4 x plus 7. Okay, so plonking in the gradient, plonking in the intercept. Now, not done yet. Work out the coordinates of the point where B intersects the x-axis. So now this is an equation with a negative fractional gradient, so it's kind of a slowly sloping down like this. We know this point here is 7 because it's the y-intercept. We want to know where it passes through the x-axis. This is the point down here. It's called the x-intercept. Okay. Now the y-intercept occurs when x is equal to 0. The x-intercept occurs when y is equal to 0, because remember the x-axis is the equation y is equal to 0. Okay, so if I want to know where this line passes through the x-axis, I want to know the value of x when y is equal to 0. Okay, so we're going to sub that into the equation. 0 equals -1/4 x plus 7. Okay, so taking my -1/4 x to the other side, I'm going to get 1/4 of x is equal to 7, and then times in both sides through by 4, I'm going to get x is equal to 4 lots of 7, that's equal to 28. Okay, so my coordinate down there is going to be x is 28, y is 0, so 28, 0. Question 49, ACB is a straight line. A is the point 0, 12. Yeah, that's the point up there, that's already on the diagram. B is the point 6, 0. Yeah, I can see that from the 6 there written there. C is the midpoint of AB. So C is the midpoint of AB. So that cuts that line exactly in half. I'm just going to draw that like that so I remember. And the line DCE is perpendicular to the line ACB. That's already been marked by that right angle there. So that's good. Okay. Work out the equation of the line DCE. So I need to know the equation of this line running up here, don't I? Okay. Right, so what do I know? Or what can I find out? Now, I don't know much about DCE at the moment, but I do know a fair old bit about this line because I've got these 2 points here and here. Okay. And because I've got those 2 points, I can work out the gradient of that line. So if I work out the gradient of that line, then I can find the gradient of the other one using the same relationship we used earlier. Okay, so let's do the gradient of AB first. For the line AB, then M1, the gradient, it's going to be y2 minus y1 over x2 minus x1. Okay, now remember this point down here was 6, 0, and this point over here was 0, 12. So this could be my x1, y1, and this could be my x2, y2 coordinates. So subbing those carefully into this equation, y2 is 0 minus y1, which is 12, divided by x2, which is 6, minus x1, which is 0. Now, does it matter which way round I label x1, y1 and x2, y2? No, but I kind of did it so that the negative sign would end up on the top, because that's just a bit neater. That was all. So I've got 0 minus 12, which is minus 12, and 6 minus 0, which is 6, and negative 12 divided by 6, that is negative 2. Okay? So the gradient of my line AB is negative 2. So what is the gradient of my line DE then? So switching to line DE, M2, that's going to be the negative reciprocal of M1 then, isn't it? Which is going to be minus 1 over negative 2, which is the same thing as a half, isn't it? Positive half. Okay, that looks about right, isn't it? Because it's a positive gradient. DE is sloping upwards. It's not sloping up super steeply, even though it's not drawn accurately. Kind of fits with my diagram, doesn't it? So M2 is equal to a half. So we know then that the equation of the line is of form y equals m, where I've got m is equal to half x plus c. So all I really need to do now is to find the value of c. Now to find c, I need a point where the line passes through. Now that's not super easy to see so far because I haven't got a point it lies through, but I know that c is the midpoint of the line going through A to B. So I want to know the midpoint. That was the other formula I should have written down at the top. Now you can find the midpoint of the line by averaging out your two coordinates. So if I take my two coordinates, x1 and x2, I add them together and divide by 2. So average my x coordinates and do the same thing with my y coordinates. y1 plus y2 over 2. Then that will give me the midpoint then, won't it? Okay. So the x coordinates are 0 and 6. So that averages out to a 3. And then the y coordinates are 0 and 12. And that averages out to a 6. Okay, so then the midpoint of my line is going to be 3, 6. So that's the point C, isn't it? Right, so I know then that the line passes through 3, 6. Okay, and so if I sub that in, then 6 is equal to a half of 3 plus c. So a half of 3 is 1.5, and 1.5 taken away from both sides is 4.5, isn't it? So c is 4.5. So then I make the equation y is equal to a half x plus 4.5. Is that what we needed to work out? Yeah, just work out the equation of the line. So that's it. Y is equal to a half x plus 4.5. Okay?
Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.